In this video, we are going to discuss about how to solve second order linear non-homogeneous differential equations with constant coefficients. We have already studied the other part which deals with the homogeneous equations. That is, we have already learned how to solve this type of equations when on the right hand side we have 0, which is a homogeneous equation. Now we will extend this discussion and try to solve the equation when on the right hand side we have a function of x. Everything remains the same. P0 and Q0 are constant coefficients. The differential equation is second order. It is linear, so it does not involve any quadratic or cubic terms. But on the right hand side, 0 is replaced by a function of x, so it makes the equation non-homogeneous. Now such an equation has a solution of this form: y equal to yc plus yp. This yc part is called as complementary solution, and it is the solution of the same equation when it is homogeneous. That is, yc is going to be the solution of the homogeneous part of the equation. So yc can always be solved by using the techniques learned in the previous lecture. Now this yp is called as particular solution. It is the any known solution of this non-homogeneous equation. So yc, how do we find out? That we have already learned. Now yp is yet a known technique. So in order to find out yp, there are typically two standard methods involved. The simplest method is to guess a solution or assume a solution. This technique works most of the times, but in certain cases, when fx or the differential equation itself is quite complicated, then sometimes it is very difficult to guess or assume a solution. In that case, we approach with the method of successive integration. Now this method always gives yc and yp both. So this method of successive integration always gives the entire solution y equal to yc plus yp. But then most of the times we prefer using the other technique because this method of successive integration is mathematically too much involved or complex process. So let us discuss this method of successive integration first. So we have already known that the equation d squared plus p0 d squared y plus p0 dy plus q0y is equal to 0 can always be converted into this form: d minus a into d minus b times y is equal to 0. A and b are the roots of the auxiliary equation. Now remember, this was the case with homogeneous form. But now here, instead of this 0, we have with us some function of x, maybe sin x, x squared, or e raised to 3x, and so on. So some function of x. So now we have to solve this equation directly using mathematics. So let us Substitute d minus b times y by some letter u. This makes this equation as d minus a. Now instead of this entire thing, we are going to write u. We must remember this. Let us call it as some equation star. D minus a times u is f of x. So now note that this d is d by dx. So I write it as du by dx minus au is equal to fx. Now this is a first order linear differential equation. Now this already has a standard solution. The solution is of this type. Suppose say we have dy by dx plus p of x times y is equal to q of x as the standard form of differential equation. Note that y is replaced by u here, p of x is replaced by minus a, and q of x is replaced by f of x. That is the only difference. So in this case, the solution is this: y is equal to e raised to minus integral p dx integration of q of x e raised to integral p dx plus c times e raised to minus integral p dx. Let us call this as constants. This is the standard solution for this type of equations. So let us apply this formula in our case. So in our case, this will be u equal to e raised to minus integral a dx integral f of x e raised to integral a dx plus c1 e raised to minus integral a dx. So u now becomes e raised to minus ax. A is a constant and integration of dx is x. Integration of fx e raised to ax dx plus c1 e raised to minus ax. Now this is the answer for u. Let us call this or denote this by a symbol q bar of x. Since it is a very large quantity and it has to be solved, this integration has to be solved. This has to be done mathematically. Let us call whatever quantity we get here by some q bar of x. Now just remember, this u is defined by us as d minus b into y. So d minus b into y is equal to u, that is equal to q bar of x. Now note here that this q bar of x is a very complicated expression which has to be solved first. But anyway, it is some function of x, that's true. Now again we replace this d by dx. So it gives us dy by dx minus by is equal to q bar of x. We note that this is again in this particular form dy by dx plus p of x y is equal to q of x. So again the solution to this will be the same, which will be the solution of this type of equation. That is y equal to e raised to minus integral p dx into integral q e raised to integral p dx plus c e raised to minus integral p dx. But only thing is that let us call now this constant as some c2 because we have already used c1 for the solution given by u. So if we use this formula here, we get y equal to e raised to minus integral. Now p is minus b in our case. So here we get minus b dx into q e raised to minus integral of b dx dx plus c2 e raised to minus integral of minus b dx. That is, y is now equal to e raised to minus minus becomes plus, b is a constant and integration of dx is x. So we get e raised to bx. Sorry, here we have a q bar. Note that, correction. Q bar of x e raised to, and a minus sign here, minus bx dx plus c2 e raised to bx. This is the required solution y of the differential equation y double dash plus p0y plus q0, sorry, p0y dash plus q0y is equal to f of x. Note that this f of x is hidden in this q of x, because q bar of x itself is a complicated expression which gives e raised to minus bx integral fx e raised to bx dx. Sorry, there's a slight correction. E raised to minus ax e raised to ax plus c1 e raised to minus ax. Now this particular process is to be performed for any given differential equation of this type. It is very tough or lengthy process if we consider the mathematics point of view, but that can always be done for any general this type of equation. That is why people always prefer to guess a solution. So let us go through an example to get a feel of it. So let us try to solve this equation. They solve y double dash minus 4y dash minus 12y is equal to 3 e raised to 5x. This is a non-homogeneous equation. The homogeneous part will be y double dash minus 4y dash minus 12y is equal to 0. Now this can be written as d squared minus 4d minus 12 into y is equal to 0. The auxiliary equation will be d squared minus 4d minus 12 is equal to 0. Now the roots for this equation are simply d minus 6 into d plus 2 is equal to 0. Correct? This factorization can always be performed. We can cross check. So the solution will be c1 e raised to minus 2x plus c2 e raised to 6x. Note that d minus a into d minus b is equal to 0 gives solution of this form 1 e raised to ax plus c2 e raised to bx. So a root will have a minus sign here, then in the solution it will have a plus sign. So the 6 appears as plus 6, but this plus 2 appears as minus 2. This will be the solution of homogeneous part. So we call it as YC, which is the complementary solution. Now we have to find out YP. For that, we have to assume a solution. Now looking at this particular form of fx, it is perfectly acceptable to assume a solution, say yp equal to a e raised to 5x. So we are replacing this 3 by an unknown constant a. Now if we differentiate this, we get yp dash equal to a times e raised to 5x into 5. Now derivative of 5x is 5. So yp dash would be 5a e raised to 5x. Now if we differentiate it again, we get 5 into 5, 25a e raised to 5x. So we have with us the yp, its first derivative and its second derivative. Now we can use these three terms in the original equation, which says yp double dash. Look at this expression. We are repeating the same expression, but we are writing it as yp instead of y, because we are finding out the particular solution yp. Yp double dash minus 4yp dash minus 12yp is equal to 3 e raised to 5x. Now yp dash is 25a e raised to 5x minus 4 times yp dash is 5a e raised to 5x minus 12 times yp, which is a e raised to 5x, equal to 3 e raised to 5x. Now this e raised to 5x gets cancelled throughout, and we are left with 25a minus 20a minus 12a is equal to 3. That is, this 20 and 12 becomes 32 with a minus sign. So this is minus 7a is equal to 3. So a is now minus 3 by 7. So we are having the value of unknown constant with us. So this yp is now, which was a e raised to 5x, now becomes minus 3 by 7 e raised to 5x. Correct? So yes, we have with us the particular solution as well. So the total solution, which is the sum of yc and yp, would be simply c1 e raised to minus 2x plus c2 e raised to 6x. Remember this expression, minus 3 by 7 e raised to 5x. This will be the complete solution of the given non-homogeneous differential equation. Thank you.